Hello everyone, my name is Szilard Pafka and I'm going to talk about gradient boosting machines. GBMs have long been considered the best algorithm for doing machine learning on tabular data, and tabular data is the data type that is most often encountered in business applications. However, with the recent enormous success of large language models and ChatGPT, the natural question arises whether gradient boosting machines are obsolete, and in particular whether large language models and ChatGPT can replace GBMs in the domain of machine learning with tabular data. This is exactly the topic I'm going to talk about in this presentation. Before that, however, let me actually introduce myself. Long time ago, I did a PhD in physics, and like most physicists, I was working in finance for a while, and then about 20 years ago, I switched, moving to what later became known as data science. I've been also organizing meetups, for example, the Los Angeles R meetup. I've been teaching at 2 universities, and I'm probably most known in the machine learning world about my machine learning benchmarks on GitHub. And of course, nothing I say here has anything to do with my employer. To begin with, so machine learning algorithms have been used in business applications at least as early since the 90s, with algorithms such as decision trees, uh, k-nearest neighbors, neural networks, and many others. And there have been tons of practical applications since the 90s, for example, fraud detection, credit scoring, marketing, analytics, manufacturing, telecom, and insurance. And there have been numerous conferences. For example, the KDD is one of the best that combined theory and practical applications in the machine learning domain. And this has been running since the 90s as well. So as I mentioned, tabular data is the data type that's most often found in business applications. It's the data of observations organized in rows and columns and usually stored in a relational database. And at least since the 2015s, I've been advocating that gradient boosting machines are the best algorithm to use for doing machine learning on tabular data. And this is with my machine learning benchmark GitHub repository. But in fact, we should have known that gradient boosting machines are very good at machine learning. So here's a paper which is not very well known, but it's from 2006 that has compared several popular machine learning algorithms across many data sets. And the ones that came to the top are, not surprisingly, random forest, neural networks, and gradient boosting machines, followed by support vector machines and many others. And R packages with implementations have existed for both random forest and gradient boosting machines. And I've been using these since actually 2006. Later on, many others have also pointed that gradient boosting machines are the best algorithm for doing machine learning with tabular data. Here's, for example, Tianqi Chen, the author of the famous XGBoost algorithm implementation, talking at the Los Angeles Data Science meetup. He compared Kaggle competitions, the different algorithms that have won the different Kaggle competitions. And at that time, he was saying that about 2/3 of the winning solutions were using XGBoost. And later, this has been also publicized by Kaggle itself, and of course by the best Kagglers, the ones who were winning the competitions. And I've been actually doing these kind of surveys on Twitter and LinkedIn, and most people in the field, after a while, they settled on the that gradient boosting machines are actually the best for doing machine learning on tabular data. However, deep learning appeared more than uh, 15 years ago, and there was this claim that actually deep learning will beat every other machine learning algorithm if you have enough data. And indeed, deep learning had enormous success beating everything else on computer vision tasks and then later in virtual environments such as games. But I was actually very skeptical for over a decade about the success of deep learning in business or practical applications until ChatGPT appeared and all the large language models, and they became a very useful tool in answering lots of questions and getting lots of very useful, good information, uh, which at the beginning was mostly text and later it was in other domains as well. So I think by now, large language models and ChatGPT have almost all totally replaced Google searches and other ways of accessing information over the internet. It can it's very good at even synthesizing all the different kind of information. So instead of doing several Google searches and trying to combine yourself that knowledge, ChatGPT can do it for you. And of course, it can also write computer code, and it's actually quite good and efficient at that. And there is also some attempts in using it to do data analysis. Sometimes it doesn't get it right, but with additional prompts and guidance, you can get something useful and it can help you be more productive. And of course, lately we see that there is also success in self-driving, which tasks have been pretty elusive for probably a decade. And of course, we have robotics. And at the end, we might have what's called AI or general artificial intelligence. And we definitely are living in a gold rush, a mad race to actually, we don't know where. So is this going to be good for humans or is going to be very bad? So this is something that we'll have to see in the next few years probably. So going back to the question whether deep learning and then in particular large language models can replace gradient boosting machines in machine learning with tabular data. Before LLMs, I actually asked myself, can deep learning outperform gradient boosting machines on tabular data? And this is from actually back in 2015. When deep learning algorithms were already pretty mature, it's just that the large language models didn't exist. So at that time, I couldn't have deep learning beat gradient boosting machines on tabular data, and I even enlisted the help of the top researchers in the field, and we couldn't manage to tune neural networks with deep learning in a way that it could beat gradient boosting machines on several tabular data sets. And then I had this jokingly almost 10 years ago, which of course it proved later on with large language model to be absolutely wrong. And it's because of the revolutionary transformer architecture which led to the large language models and ChatGPT. So the question is whether deep learning or the transformer architecture, can it be tweaked in a way that is going to be very good on tabular data and beat gradient boosting machines? And there have been lots of algorithms that have been tried to be developed with this respect. And there is a great paper from 2022 comparing the performance of these algorithms versus more traditional machine learning algorithms on many data sets. And the conclusion was that actually gradient boosting machines, you can see XGBoost and CatBoost, are still at the top. They are easily beating all these other deep learning with transformers and different other architectures based on deep learning. So still, gradient boosting machines appears to be the best for tabular data. And of course, what matters for machine learning is also how you clean your data, how you create features, how you tune your hyperparameters, and also maybe you run several algorithms and create an ensemble, which also improves on performance. And of course, the whole process of data science is important, starting with collecting the data and exploring it, visualizing, cleaning it, and then the standard machine learning, the modeling, but also the validation and the deployment. And at the end, your boss requires you to make more money to the company you're working for, and they don't care about what tools you are using. So use the best tools for the job, whether it is gradient boosting machines or deep learning or large language models. The question is whether large language models and ChatGPT and AI are intelligent, and can they figure out what's the best algorithm to use, including themselves. So if you ask ChatGPT what are the best algorithms for doing machine learning on tabular data, actually gradient boosting machines is what always comes at the top. However, before we expand on this, let's talk a little bit about what these gradient boosting machines are exactly. So GBMs are built on decision trees, and the various boosting approaches, they are training decision trees in sequence, and each decision tree is trying to fix the errors that I made by the previous trees. And historically, the first boosting algorithm was AdaBoost, and then later the gradient boosting algorithm was introduced by Friedman, and it has a very good description in this wonderful book, Elements of Statistical Learning by Hastie, Tibshirani, and Friedman, which I highly recommend, and it has a freely downloadable PDF on the internet. Around 2014-15, I was interested in using GBM on a larger scale, and I was looking in what implementations are available there and how they perform. I was looking at open source. We love open source because it's 100% free, but also because it has a great community like meetups and like this conference. And also actually it has better documentation by many of the commercial products and books, Stack Overflow, and now I would use ChatGPT. And all these implementations have been available in both R and Python. So I started this GitHub repository, Benchmark ML, in 2015, and you can take a look. It has these kind of scalability graphs of runtime and memory usage and AUC as performance for classification. And the gist of it is that the best at the time were XGBoost, which was actually quite in its infancy as development, and also H2O. And later on, LightGBM has been open sourced by Microsoft, and also CatBoost appeared. And all of these had R and Python implementations. But many would ask, how can I use this single server implementations on my big data? Fortunately, most people don't have big data, and this is also proven by surveys. So what most people have, they have raw big data, and that can be refined for machine learning. And by that time, the data is not as big, and it will likely fit in the memory of a single server. So for example, you don't do machine learning on clicks, but you do it on user behavior, and that refined data is much smaller and usually fit in the RAM of one server. It did that even like 10, 15 years ago when you could get a few hundred gigabytes of RAM, and then later on this has increased to much higher values. While most people's data, once refined for machine learning, has been actually relatively small. What people always wanted is not machine learning of bigger data or on big data, but faster machine learning. And we want fast machine learning because we run lots of models. We do cross-validation, we do hyperparameter tuning, which means running many hundreds of models. Then the best models are combined into an ensemble. So again, we're running lots of models. We want these not to take forever, so we want fast machine learning. Later on, I revamped this GitHub repository into one specifically targeting GBMs and only the best performance, and they also happen to be the ones that show up in surveys that are the most used. So XGBoost, LightGBM, H2O, and then later on CatBoost. And I've been doing these surveys about usage over the years, and probably in the last 5 it didn't change at all. These tools have become pretty mature, and the usage doesn't change, the performance also doesn't change. So which are the best? If you want fastest training, then XGBoost and LightGBMs have been traditionally the fastest. This is initially on CPUs, but later on there are GPU implementations, and on that one the XGBoost implementation is the fastest. If we look at memory usage, is also the fastest, are usually the most efficient in memory usage, like on CPU, LightGBM, on GPU, XGBoost. But I still like H2O because H2O makes it very easy to deploy machine learning models. With a few lines of code, you can spin up web service that can take requests, so a REST API, and provide the scores over the web. So it's very easy to integrate into practical business applications to deploy the machine learning model in production. All of these have a very nice API. It's very easy to train and use these models, a few lines of code. Of course, when training, you have lots of parameters. These models are very complex. The most important hyperparameters are, of course, the number of trees, the maximum depth of the trees, and the learning rate. But there are many other that can be tweaked and tuned. And there are many tutorials over the internet on how to tune gradient boosting machines. So you can look at that if you want to get the best performance. So here's a summary table in which algorithms are the best in what. So LightGBM if you want the fastest training on CPU, XGBoost if you want the fastest training on GPU, and H2O if you want the easiest deployment. So the way you obtain the absolute best performance model and you win, for example, Kaggle competitions, this has not changed, is you do some exploratory data analysis, then you run a couple of models, typically gradient boosting machines, and a few others, and then you combine the best performing models into an ensemble. So what if we ask now ChatGPT how it would solve a machine learning problem? So here is a simple prompt describing briefly a machine learning problem with tabular data, and we are asking how it would solve it at a high level. And it comes up with pretty reasonable information. So it breaks down the problem into many topics, and each of these are discussed pretty well. And if you ask follow-up questions, it can go into detail. So for example, of course, it mentions that you need to split the data into train, test, and even mentions more advanced topics such as data leakage. And also it knows that you need to do data cleaning, and it gives you suggestions on that, and feature engineering. So all the things that I mentioned previously in the talk that human experts are doing. What about modeling? So modeling, not surprisingly, it suggests using gradient boosted machines or gradient boosted trees. So implementations like XGBoost, LightGBM, CatBoost. So this is not surprising since ChatGPT and all the others have been trained on all this public information like Kaggle forums where people were discussing how to solve machine learning problems. So if you ask it to generate some code, it will. And if you ask it to generate R code, here it is. It comes up with something similar to the code I showed before, how to train an XGBoost model. So again, not surprisingly, it has seen a lot of this code in the public information that it has been trained on. Now I'm trying to press it to use itself instead of gradient boosting machines. So I'm asking, why are you using traditional machine learning? Can you just use yourself instead to get better results, since ChatGPT is so great at text? And the answer is that yes, I can, but the evidence still points toward traditional supervised learning, like gradient boosting machines, that it's a better choice for solving this kind of machine learning problems with tabular data. And again, if I'm pressing which are the top 5 machine learning algorithms for machine learning with tabular data, then it will give you the same LightGBM, CatBoost, XGBoost. So it seems that at this point, both human experts and also AI agrees that if you have tabular data, then gradient boosting machines are still the best way to do machine learning on this kind of data. So is there any role for LLMs in machine learning with tabular data? Of course, and as I shown, they can be very useful for generating ideas, for giving you advice on a specific topic, or even generating code. And here are some of the tools that are either for idea generation or more focused towards the coding. So what's next? What's gonna happen next in this domain and more general in AI? I have no idea. It's very hard to predict. I think the only thing we can predict is that there will be changes for sure, and the changes are coming pretty fast. Uh, and the other thing I know that we'll need to learn and adapt to these new changes. So finally, here are some references to some of the GitHub repositories I've been talking about and a few more. And then here is my contact. If you want to reach out, please feel free. So thank you so much. And I think now we can open for questions.